For centuries, people's ideas about time depended on the way the sun moved across the sky. At midday, the sun was at its highest point. One day was the time it took the sun to reach its highest point again. Of course, it was not really the sun that was moving, it only appeared to move because the earth was rotating once per day. We now divide the day into 24 smaller units called hours, but our modern hours are rather different from those of 600 years ago. Before mechanical clocks came into use in the 14th century, an hour was 1/12 of the period of daylight. In summer, daylight lasted longer than in winter, so summer hours were longer than winter ones. With the arrival of mechanical clocks, hours became fixed. As clocks became more accurate, time could be measured in smaller units, minutes and seconds. Today, some scientific clocks can measure time in picoseconds, millionths of a second. Clocks may use the same length hour, but they are not all set to give the same time. That is because the sun appears to be at its highest point in the sky at different times depending on where you are on the Earth's surface. For example, when it is midday in London, England, it is midnight in Wellington, New Zealand. Before the 1880s, everyone used their own local time. In Britain, for example, clocks in London were about 10 minutes ahead of those in Bristol. When railway timetables were first introduced, this made life difficult. So, in 1880, Britain adopted the average time at the Greenwich Observatory as its standard. It is still called Greenwich Mean Time, GMT. Since 1884, the world has been divided into internationally agreed time zones. In most cases, you alter your watch by 1 hour when passing from one zone to the next. Nowadays, scientists use a very accurate definition of the second as the starting point for all time measurements. The definition is based on the natural frequency of light waves emitted by certain atoms of cesium gas, and the instrument used for the measurements is called an atomic clock. Defining a second in this way may sound complicated, but it gives a result that never varies. The frequency of the light waves is not affected by temperature or any other factor which can alter the timekeeping of other clocks. Accurate time measurements show that the speed of the Earth's rotation varies slightly. We are all used to leap years, when an extra day is added to the calendar so that it does not go out of step with the seasons. Sometimes, leap seconds have to be added as well to correct for slight changes in the length of the day. For example, the very last minute of December 31st, 1998 was made 61 seconds long so that January would start a second late. Sometimes, time signals are given on the radio to mark the hour. Normally, you hear 6 bleeps in succession, but when a leap second is added, there are 7 bleeps. As a sailor, finding your position north or south of the equator is relatively easy. It can be calculated from the angle of the sun above the horizon at midday. But finding a position east or west is much more difficult, and it relies on good timekeeping. Imagine that you are somewhere in the Atlantic Ocean. When you left Greenwich, you set your clock. Now, it says 12 noon, but the sun has only just risen. Indeed, you have to wait another 6 hours before it is midday locally and the sun is at its zenith, highest point, in the sky. You can use this information to calculate how far around the globe you are. Compared with Greenwich, your midday seems to be 6 hours late. As the Earth does one turn in 24 hours, it must have rotated a quarter of a turn in 6 hours. So you must be 90 degrees west of Greenwich.